Bismillahirrahmanirrahim. Assalamu alaikum. This lecture is for BBA 2. The subject is Principles of Microeconomics. This is our lecture number 8, which is delivered by Ms. Zahra Arif. In this lecture, we will discuss about the indifference curve and the budget line. Indifference curve analysis. The utility maximization rule previously discussed requires individuals to measure and compare utility like as a business would measure and compare cost or revenues. Such cardinal utility is measured in a unit such as 1, 2, 3, and 4 and can be added, subtracted, multiplied, and divided, just like the cardinal numbers in mathematics. More importantly, cardinal utility allows precise quantification of the marginal utilities upon which the utility maximization rule depends. In fact, the marginal utility theory of consumer demand that we explain in the body of this chapter digs squarely on the assumption that we can measure the utility. The reality, however, is that measuring cardinal utility is highly difficult at best. Can you, for instance, state exactly how many utils you are getting from reading this lecture right now, or how many utils you would get after watching the sunset? To avoid this measurement problem, economists have developed an alternative explanation of consumer behavior, an equilibrium in which cardinal measurement is not required. In this more advanced analysis, the consumer must simply rank various combinations of goods in terms of preferences. For instance, Sally can simply report that she prefers 4 units of A to 6 units of B without having to put number values on how much she likes either option. The model of consumer behavior that is based upon such ordinal utility ranking is called indifference curve analysis. Budget line. What is attainable? First of all, we need to know that what is budget line. A budget line is a schedule or a curve showing various combinations of two products a consumer can purchase with a specific money income. If the price of the product A is $1.50 and the price of the product B is $1, a consumer could purchase all the combinations of A and B shown in the table in the figure with the 12 money income. At one extreme, the consumer might spend all of his or her income on 8 units of A and having nothing left to spend on B. Or by giving up 2 units of A and thereby freeing $3, the consumer could have 6 units of A and 3 of B and so on. Let's have a look on the diagram and the table that. Figure 1 also shows the budget line graphically. Note that the graph is not restricted to the whole units of A and B as in the table. Every point on the graph represents a possible combination of A and B, including fractional quantities. The slope of the graphed budget line measures the ratio of the price of B to the price of A. More precisely, the absolute value of the slope is PB over PA is equal to 1 over $1.5 is equal to 2 by 3. This is the mathematical way of saying that the consumer must forego units of A measured on the vertical axis 2 by 3 units of B measured on horizontal axis. Look at this. That consumer has a budget of 12 rupees, $12, and the price of A is 1.5 and the price of B is $1. What is he doing? He is buying either all of A units. Now how he get 8 over here? By dividing 12 by 1.5, but we get 8. If we are getting 8 units of A, then we have nothing left for B. Let's suppose that he buys 6 units of A, then he will buy 3 units of B. If he buys 4 units of A, he will buy 6 units of B. If he'll buy 2 units of A, then he will buy 9 units of E. Now look, to remain on the budget line, what he is doing, if he is foregoing one unit of A, then he is getting something of other unit of B. The budget line has two other significant characteristics: income changes and price changes. The location of the budget line varies with the money income. An increase in income shifts the budget line to the right. A decrease in money shifts it to the left. To verify this, recalculate the table in the figure 1 assuming that the money income is 24 or $6. What you need to do, if it is 24, you will double it. Double all the quantities of A and all the quantities of B. And if it is 6, then what you will do? You will halve the quantities of A and halve the quantities of B. Price changes. A change in product prices also shift the budget line. A decline in the price of both products, the equivalent of an increase in the real income, shifts the curve to the right. You can verify this by recalculating the table in figure 1 and replotting figure 1 assuming that price of A is 0.75 and price of B is 0.50. Conversely, an increase in the price of A and B shifts the curve to the left, assuming the price of A is 3 and the price of B is 2. Do this and send it to me. Indifference curve. What is preferred? Budget line reflects objective market data, specifically income and prices. They reveal combinations of product A and B that can be purchased given current money income and prices. Indifference curves, on the other hand, reflect subjective information about consumer preferences of A and B. An indifference curve shows all the combinations of two products A and B that will yield the same total satisfaction or total utility to the consumer. The table and the graph in the figure 2 represents a hypothetical indifference curve for the product A and B. The consumer's subjective preferences are subject that he or she will realize the same total utility from each combination of A and B shown in the table or on the curve. So the consumer will be indifferent, will not care as to which combination is actually obtained. This is a hypothetical indifference curve. What is the indifference curve? The curve shows different combinations of two products which gives a consumer an equal level of satisfaction. Let's suppose a consumer is getting more of X, he is foregoing something of Y. Now, from this we can see that he is foregoing something of Y. But firstly he decreased 3 of Y, then he decreased 2 of Y, then he forego 1 of Y. So he is foregoing lesser and lesser of Y. That is known as diminishing marginal rate of substitution. What is marginal rate of substitution? For getting something, you are foregoing something else. That is known as marginal rate of substitution. So here we can see that the marginal rate of substitution for getting X, he is foregoing Y. Firstly, he forgoes 3Y, then 2Y, and then 1Y. So that is the marginal rate of substitution. But this is in decreasing trend. So we say that this is law of diminishing marginal utility. And remember that every point on the indifference curve will yield a same level of satisfaction for, let's suppose that we say that the level of satisfaction is K. So it will yield a K level of satisfaction at every point on the indifference curve. Now, indifference curve has several important characteristics. Number 1 is indifference curves are downward sloping. Number 2 is indifference curves are convex to origin. And number 3 is indifference curves do not intersect. A consumer indifference curve. Look at this. There are different 4 combinations J, K, L and M, and the units are 12, 6, 4, 3. He is decreasing the units of A but increasing the unit of Y, increasing the B. He is increasing the equal units of B, that is 2, 2, 2 and 2, but he is foregoing lesser and lesser units of A. Firstly, from 12 to 6, he forgoes 6 units of, then 6 to 4, 2 units, then 4 to 6, 1 unit. With the help of this, we have plot an indifference curve, which is downward sloping and convex to origin. Number 1 is downward sloping. An indifference curve slopes downward because more of one product means less of the other, if total utility is to remain unchanged. This property implies that an indifference curve has a negative slope. Indifference curve being downward sloping means that when the amount of one good in the combination is increased, the amount of the other good is reduced. This must be so if the level of satisfaction is to remain the same on an indifference curve. The curve that reflects inversely related variable is downward sloping. If the amount of good X is increased in the combination while the amount of Y remains unchanged, then new combination will yield more level of satisfaction. Indifference curves are convex to origin. An indifference curve is therefore convex bore inward to origin of the graph. Its slope diminishes or becomes flatter as we move down the curve from J to K, K to L, and so on. Technically, the slope of an indifference curve at each point measures the marginal rate of substitution of the combination of two goods represented by that point. The slope or marginal rate of substitution shows that the rate at which the consumer who possesses the combinations must substitute one good for the other, say B for A, to remain equally satisfied. The diminishing slope of an indifference curve means that the willingness to substitute B for A diminishes as more of B is obtained. If we increase more of one commodity, we will forego less and less of other commodity. Then that is why indifference curve is convex to origin. Third is indifference curves can never intersect each other. Third important property of the indifference curves is that they cannot intersect each other. In other words, only one indifference curve will pass through a point in the indifference map 1. His property can be easily proved by first making the two indifference curves cut each other and then showing the absurdity of self-contradictory result in 2. In this figure 8.5, two indifference curves are shown cutting each other at point C. We may clearly see that at IC1, B is equal to C because on an indifference curve, each point will yield a same level of satisfaction. So at IC1, B is equals to C and at IC2, C is equals to A. According to the transitivity property of mathematics, this implies that A is equals to B, but in reality, it is not true. We may clearly see that A is on the higher indifference curve, so A yields higher level of satisfaction than B. So A is greater than B. So we conclude that IC curves can never intersect. This is an indifference map. An indifference map is a set of indifferent curves. Curves farther from the origin indicate higher level of total utility. Thus, any combination of product A and B represented by a point on I4 has greater total utility than any point of A and B represented by a point on I3, I2, and I1. Thank you.